This is the 8th video out of 10 for the tutorial that describes setting up the simplest simulation with Lumerical software. I would like to remind you that I provide a PowerPoint slide supplemental to this video tutorial. This part discusses setting up a detection monitor to analyze fields in the simulation domain. By the end of the previous video, we have already created all the object, citation source, and mesh that we need for the simulation. The next step is to set up a field monitor. Again, we go to model and we access the section with the script. Now we need to add the line select monitor. Similar to the setting of the excitation source, we introduce two parameters for the in-plane X and Y direction. I'm just copying it from the script of the rectangle. For the Z direction, we simply introduce a coordinate of the monitor position. We use a variable H monitor that we defined earlier in the list of parameters. So it is set Z, and here we write the monitor. Similar to the previous cases, the software again tells us that there is something wrong when we click test, shows some errors. It is because the monitor has not been created yet, but it's okay, and we're going to fix it right now. So we click OK. Let's create a monitor we need to use for detecting the transmitted power. In the top panel, we locate the section called monitors. And here we need to select frequency domain fielded power. This is the characteristic that we need to detect and analyze the transmission coefficient. Once we create a monitor, its geometrical parameters are taken from the script section, and the monitor is defined with the correct dimension and Z coordinate position. We can see the monitor in this region in the simulation domain. As the variable H monitor has a negative value, the monitor is located on the substrate side of the simulation domain. Now we open the settings of this monitor by clicking Edit Object. We need to set global monitor settings, and we click that button. In this box, we determine the number of frequency points. It's basically the spectral resolution of our transmission plot. We definitely need to change it because the default setting of 5 points in the spectrum is definitely not enough. We need to have, for example, 50 or 100 points in that plot. Click OK. And the tab geometry, again, dimensions are populated automatically and correctly because of the script we wrote earlier. In the tab data to record, we need to select what fields and other quantities we are going to analyze. In fact, we want to analyze the Z component of the pointing vector. So we remove all these default checks as we don't need, and we choose PZ. we click OK and leave the monitor setting. As always, it's important to save the project regularly. And this completes the 8th video on the numerical simulation with the Lumerical FDTD tool.